So warm-up number 7, 3 itty-bitty problems. Number 1 is to simplify as much as possible that expression. Number 2 is to solve that equation. And number 3 is to solve that inequality. So do me a favor, share with your neighbors, see what you got for all 3. Help them out if they need extra support for that. All right. Number 1. What'd you get for number 1? About Danny. What'd you get for number 1, Danny? Yeah, what you got? And minus 2y. And if you got something like that in any order, okay. However, in standard form, what would go first, everyone? The x, so it would be negative 2x minus 2y plus 1. Okay? All right, double check your work. Number 2. Just for the sake of reviewing, I'm going to go over that one. Here it goes. I'm going to go pretty quick, so stay with me. Line down the equal sign. I'm going to focus on the left side. I need to simplify everything on the left side, so I distribute the 3. This is 3x plus 3 minus x. Can I combine stuff? 3x and negative x. One of these cancels one of those, so we're left with 2x plus 3. Hands of you are right there so far? Yeah? I'm going to go to the right side. Distribute, so I end up with 2x minus 6, and I'm going to distribute a negative 1 because of that negative to the other parentheses, negative 1x minus 4. Can I combine stuff? Yes. 2x minus 1x is 1x. Negative 6 and negative 4, they're the same sign, so this is negative 10. And if you're right there. All right. Get all variables to one side. I'm going to start with the smallest one. The opposite of a positive x, it's minus x minus x. We're left with x plus 3 equals negative 10. And then last but not least, minus 3 minus 3, x equals negative 13. And if you got that by yourself, all right, good. Okay. Let's go to number 3. Number 3, here we go. We have fractions all over the place. Let's get rid of the fractions. Bless you. What would be our common denominator, everyone? 20. Oh, no, it's 24. So over 1, distribute. That would be 24 over 3x, and it's a negative, plus 24 times 2, that's 48 over 4, greater than, bless you, 24 times 4 is 96 divided by 24. Line down the inequality symbol, I'm going to simplify. Here we go. This is negative 8x plus 6 greater than 4. So far so good, yes? Did I make a mistake? Oh, it's 12, yeah. This is 12. I did that on purpose to see if you were paying attention. That's pretty good, right? I'm telling you, I got this. Next, subtract 12, subtract 12. We end up with negative 8x greater than negative 8. Last but not least, divide by negative 8, divide by negative 8, bless you. X is greater than 1. And if you got that, Let's check in. Check this out. Bam! Let's go. Say never Y, flip the symbol, please. Yeah, divide or multiply by a negative. All right, set that aside. Copy the agenda underneath that for today. Right underneath that, copy the agenda. Warm up number 7. Today we're moving on to compound inequalities. You're like, oh yes, inequalities my favorites. All right, good. Tonight's home plate is only 8 problems. All right. Copy the Nearpod code for tonight, 5SM4X. Since we're not using the Nearpod here in class today, the presentation that you see today here on live, you can go to it at home. Now, let me pause the music really quick. Let me just elaborate on the home plate. Last night's home plate was this one, yes? All right? Now, if I was to ask you to go to Canvas, turn it in, you cannot turn it in because it doesn't allow you, because when it doesn't allow you, I'm going to ask for it in class by your name. So that means you're going to come over here, march all the way, but hold on. March all the way over here, show me your home plate. Correct it really quick. Since it's only 4 problems, I'm like a Terminator. Bam. Okay? So, for those of you that think about your previous years. Those of you that were not consistent with your home plate, you need to have a very good excuse when you walk all the way over here without any home plate. So, when you walk all the way over here, come see me. Mr. Q, I'm a Power Ranger and I was saving the world. Whatever it is, I want to hear it. It has to be a very good one. It can't be like, I forgot. Wow. Or, I don't know. What? I heard that one before, and I'm like, why didn't you do it? I don't know. What? Anyways, does everybody get the idea? Okay? Now, I did this on purpose today. However, I am going to change it so that you are able to turn it in online by the end of the day at 3:25. Okay, I'm going to do that right in the next lunch. So that means I'm not going to put some of you on the spot today. You're like, but I'm giving you heads up. That's how it's going to go throughout the school year. Some days I'm going to pick it up. Some days you're going to turn it on Canvas. But why? I want accountability. Does that make sense? Yes, Mr. Q. All right, good. Anyway, tonight's home plate, it's this one. That's why you needed that Nearpod code. Don't copy that. You have the Nearpod code, yes? It's a lot of stuff, so don't copy it. You can do that at home. All right? So, look up to the screen, write your utensils down. Quick intro once again to make sure we understand equations and inequalities. I started with a balanced scale. I said if I was to add weight to this side, what happens to this side? It drops. In order to balance it, whatever we do to one side, we do to the other side. If I add more weight on the other side, then it drops. And we said that that's where we get the equations and inequalities. Once again, if you don't see it, here it goes one more time. The original bar was right here, and it dropped to right there. What is here? 8. What is over here? 11. And there's my inequality symbol, and that's where we get our equations and inequalities. That's why we got to keep it balanced in order to be an equation. All right. So our objective for today, I can solve one variable equations and inequalities, so get a Cornell note ready. You do not need a Frere model today or that organizer. You don't need one of those. Just your Cornell notes with the objective at the bottom left. I can solve one variable equation and inequalities. So what are we still looking at? What concept? One variable equations and inequalities. And then what are we doing? We're solving it. Write this one at the bottom left of your paper, at the bottom left of your paper. Courtney Jean, can you help Anthony show him how to take notes? All right. Give some time to set up. All right, I think we got it, yes? Once again, simplify, isolate, plot, and check. We're going to be doing that today, okay? Now, the graphing portion of inequalities has given people a hard time in the past. I don't know why, but today I want to address that. So on your paper, I want you to write inequalities. Inequalities. Let's start with that to clarify before we get into the compound inequality for today. Inequalities. All right, example Q. Here we go. Write this down. 5 is greater than 2x plus 1. All right, so let's do this one together. Line down the inequality symbol. Let's see. What was the first step from the 4? Simplify. So let's simplify the right side. Can we simplify the right side anymore? No. The left side, no. So step 2, isolate. That means we need to leave the x by itself. Minus 1 minus 1. We're left with 4 greater than 2x. I still need to isolate, so I need to divide by 2. Divide by 2. So 2 is greater than x. 2 is greater than s. All right. So simplify, isolate. So we left the x by itself. What is the next step? Simplify, isolate, plot your solution. So I want you to draw a number line to the right. Right away, I want you to plot or label 0. All right. So at this point, before you start graphing, writing utensils down, please. Look up to the screen. This is what I want to clarify. I want to make sure that you guys understand what we're looking at in regards to graphing. All right, here it goes. Especially those of you that struggled with this in the past. Here it goes. When we're talking about inequalities and their graphs, the number that we come up with at the end, this is what we call dividing point. Why, Mr. Q? Because it divides the number line into 2 sections. Why 2 sections? Because one section is the solution, the other section is not the solution. Let me repeat that again. The number we come up with, this one, is known as the dividing point. Why, Mr. Q? Because it divides the number line into solutions and no solutions. Now, how can we know which direction to shade? You have to check. Now, some of you already have a shortcut in your noodle, you already know, but let me show you for sure how to check. Let's say I didn't know. And I'm like, you know what? I'm going to shade to the right. The next number after 2 should be what? 3. Okay, I'm going to check if that works. So instead of x, what do I write? 3. Let's see if it works. Bring everything else down. And let me read this. 2 is greater than 3. Is that true? No, that is not true. So I cannot shade to the right. So if all that side does not work, that means I have to shade it what? In the other direction. So I go in this direction. Is it making sense? Yes? All right, so do that really quick. I'm still not done. We have to do one more thing. Next, you got to tell me if it includes 2 or if it excludes it. Or in other words, open point or closed point. Does it have an equal sign underneath the inequality symbol? No, so that means it does not include 2. So to indicate that we don't use 2, we do an open point. Open point. Once again, I hope for some of you this is confirming some of the things that you were missing, okay? Because we're going to get into some funner stuff, okay? Once again, what is the number we come up with once we solve the inequality? It's called a dividing point. Why? Because it divides the number line into solutions, and then the other side is no solutions. That means these do not work. So, before I move on, tell your neighbor another number that would not be a solution to that. Another number that would not be a solution to that. Yeah. Some of you are like very original. You're like 4. Wow. How about 23 Michael Jordan, right? It's on that side. It wouldn't work. Okay. Now tell your neighbor a number that will work as a solution. A number that will work. All right. All right, a number that will work. Jasleen, go. -4. Hands if you agree that that does work. Yes, we can actually see it, that it's in the shaded region. From 1 to 5, I'll come through you with the graphing portion. Did we check? Yes, Mr. Q, we checked by checking a number to see if it worked for the graph. All right, let's do another one. Here we go. Example Super Q. Example Super Q. Let's do 4x minus 5 plus 2x, bless you, greater than x plus, give me a number, 3. I had to do it. All right, let's do this one together. Here we go. Line down the inequality symbol. All right, so let's go over the process again. Simplify, isolate, plot, check. First step, simplify. We need to simplify both sides. So let's start with this side. Can I do anything here? Yes, combine the 4 and the 2, so that gives us 6. Okay. X, bring down the -5, greater than x plus 3. Can we simplify any more? No. How about this side? No. Okay. What would we do next? Let's see, simplify, isolate. That means we need to send the variables to one side. So what do I do here? I'm going to start with the smallest one, subtract x. We got 5x minus 5 greater than 3. All right. From there, we still need to isolate, so plus 5, 5x greater than 8. I still need to isolate, so I divide by 5, x is greater than, let's see, 8 divided by 5, it's in there once, subtract, that's 3, add a decimal, 0, so that is 6, so this is 1.6. All right, so far so good? Yes, Mr. Q. All right, so what would we label this one that we actually got from solving the inequality? DP. Tell you what DP stands for. Dividing point. Ah. All right, draw your number line on the side. Start with 0. And I'm going to go 1, 2, 3, just to have that. And where would I put my dividing point? At 1.6 between 1 and 2, so about right there, 1.6. All right. So, once again, some of us already know which direction it goes, but I want you to check the number. So, let's go with Marley. Which number do you want to check? Do you want to check a positive number or a negative number? Marty said 2. All right, so let's check 2. So instead of x, we're going to write what? 2 bring everything else down, greater than 1.6. Question, is 2 greater than 1.6? Yes, that is true. So that means we are going to shade towards the 2. All of these are my what? Solutions. Now question, is it an open point or closed point? Open because it doesn't have an equal sign. That means we do not include 1.6 as our solution. It's only our dividing point. From 1 to 5, I'll come to you with inequalities in their graphs. Okay, 23, let's go. We got it, yes? All right, because we're about to crank it up a bit. Yes, y'all ready? All right, so with that said, writing utensils down, look up to the screen. There it goes. Ready? If I was to solve this one, first thing I do is what? Subtract 1 to each side. That gives me -6 less than x. The graph, here it is. There's 0. What's my dividing point? -6. Okay. So if I was to try a number, what number do you guys want me to check? Let's say 5. I write it there. Is -6 less than 5? Yeah, so that means I'm going to shade with an open point because there's no equal sign. I'm going to shade to the right. So far so good? Yes. All right. Let's do another one. Look at this one. Writing utensils down, look up to the screen. Once again, what do I do here? Subtract 1. We end up with x less than 1. This is my dividing point. Once again, 0. There's 1. Okay. So I'm going to check with 2. Is 2 less than 1? No, I'm not going to shade that way because 2 didn't work. So I'm going to shade with an open point to the left. Okay. Now, today's objective for equations and inequalities, today we're going to focus on inequalities. We're focusing today on compound inequalities. Listen to the word, compound inequalities. The word compound means what? Combine. You've heard of that, right? Okay, well, check this out. I'm going to combine these 2 inequalities into one. Look up. Let's go. What did I do? I combined it, both of them. What do you notice? Both graphs combine, but also both inequalities. You guys see the inequality up here? This is known as a compound inequality. Today we're going to focus on this. Since we're already done with the baby inequalities, we're focusing now on the next step. Copy this one. Example 1. Good intro, yes? Yes, Mr. Q, I was paying attention. All right, good. Example 1 says, solve graph, check, and write the solution set. Write the solution set. And I'm trying to hit all the points that you've covered already in Algebra 1, hopefully. And this should be review. For some of you are like, I don't remember this, Mr. Q. Well, it's coming. All right? So it says, solve graph, check, and write the solution set for -5 less than x plus 1 less than 2. Writing utensils down, look up to the screen. I'll have you copy at the end. Here it goes. Ready? So, how do you solve this? Well, line down the inequality symbol, and I start with, what was the first step? Simplify. Can I simplify the left? No. The middle? No. The right? No. Step 2, isolate. Leave the variable by itself. What do I do here? -1, but I do that to all sides. This is -6 less than x less than 1. Copy that, please. Let's go. Oh, yeah, we got this. All right. Underneath that, I want you to draw a number line. All right. So here goes the graphing portion. This is where it gets a little tricky. Ready? Write your utensils down. Look up to the screen. I'm going to use different colors just so that you can see exactly where I'm at. You don't get lost. So I'm going to start with red, and I'm going to highlight the first part of the compound inequality. All right, what is my dividing point? -6. Okay. So for that, I'm going to check a number. Me, Mr. Q, I usually check 0. Okay? So I'm going to check 0 to see if it works, if I'm going to shape that way. So I'll substitute here underneath the 0. I bring down the -6 less than. Is -6 less than 0? Yes, negative are usually less, so that is true. So that means I'm going to shade towards the 0. All right? Does it have an equal sign? No. Open point. Let me go to the next one. Look up. I boxed the second part of the compound. What is my dividing point? 1. There it is. All right. Next, I'm going to check again, and I usually like to check with the number that's already there, which is 0. Bring everything else down. Is 0 less than 1? Yes, so that means I'm going to shade towards 0. All right. So, and it's an open point. So, this is true. Copy that, please, and we'll talk about what we got at the end. Pause that really quick. All right. From 1 to 5, how can you up to right there? Okay, not bad. Let's see. Did we solve? Yes. Did we graph? Yes. Did we check? Yes and yes. Did we write a solution set? Not yet, but let me make sure that we are on the same page. So where do both graphs intersect? In here. So in here, you're going to write solutions. Those are the only solutions where both graphs intersect. What are the solutions? Where both graphs intersect. What are the solutions? Where both graphs intersect. What are the solutions? Where both graphs intersect. This is what we call, above that, I want you to write the word and. And inequalities is when you have two graphs that intersect. Those are known as and inequalities. All right? So, last thing, we need the solution set. Hopefully in your Algebra 2 course, they showed you how to write solution sets. So, writing utensils down, look up to the screen. Here it goes. I'm going to take my graph, and I'm going to write my solution set from here. Look up, please. Solution set for all x's, that means any number that I substitute for x, such that, what is my dividing point? -6. What is the other dividing point? 1. What are my solutions? All in here, represented by what? X, less than, and close your solution set. Copy that, please. So if you notice, the solution set has the inequality symbols always pointing to the left. That is true for these and inequalities. All right, once again, what are these brackets called? The set of all x's such that, that's what it says. And then all arrows to the left. All right? So, we did one together. Let's do another one. Here we go, just to make sure we got it. Copy this one, example 2. Example 2. I'll give you a head start. See if you can do that one as much as you can, and then I'll ask for participation. Copy and go. And once again, solve, graph, check, and write the solution set of -9 less than x minus 10 less than -5. All right, show your neighbor, see what you've done so far. See where you're at. All right, here goes the process. Lines down the inequality symbols. There it is. Can we simplify the left? No. The middle? No. The right? No. So therefore, isolate the x. So then we add 10 to all sides. 10 to all sides. So we end up with 1 less than x less than 5. Hands, have you got that? All right. Going to the graph. All right. I'm going to focus first on the first part of the compound, which is this one. What's my dividing point? 1. It's an open point. All right. Now, like I said, I like to check the number that's already there so I can see if it works, if I'm going to shade to the left or towards 0. So, let's see. Is 1 less than 0? No, that's false. So that means I can't shade to the left. I have to shade to the right. All right. Next, the second part of the compound. My dividing point is 5. It's an open point because it doesn't have an equal sign. And I'm going to test 0 again for x. Is 0 less than 5? Yes, that is true. So I'm going to shade towards the 0. So what are my solutions? Only what's in between. Solutions. And this is a what? An inequality. So let's write our solution set. Solution set of x such that, what do I write first? 1. What do I write at the end? 5. What do we write for the solutions? X. And arrows to the left. And have you got something like that? All right. From 1 to 5, how comfortable are you with that so far? All right. 5, 4, software. Let's crank it up a bit. Yes? You're like, come on, Q, these are cake. All right? Copy this one, example 3. Don't copy the instructions, you already have it, but the inequality is 8 less than 3x minus 1 less than or equal to 11. Line down the inequality symbol, line down the inequality symbol. All right? Can't simplify there, there, or there. So to leave x by itself, where do I start? What do I do first? Danny. Add 1 to all sides. Thank you. Add 1, add 1, add 1. We end up with 9 less than 3x less than or equal to 12. The x is still not by itself. What do I do next? Everyone. Divide by 3, divide by 3, divide by 3. We end up with 3 less than x less than or equal to 4. Ooh-wee. Man, these are fun, right? The funner 0. All right. So, what's my dividing point for the first part? 3. Open point? Yes. All right. What number do I test? I'm going to test 0 again. So 0, 3. Is 3 less than 0? No, that's false. So I'm not going to shade towards 0. I'm going to shade on the opposite direction. There it is. Next, my other part of the inequality, the compound, it's 4. Dividing point is 4. Open or close point? Close because there's an equal sign on this one. So this one is going to be a solid point, a solid point. Let's test a number. Let's test 0 again. So Is 0 less than or equal to 4? Yes, so I shade towards 0. So what are my solutions in between those two numbers? Solutions and. Write your solution set, see what it looks like. Should have written x such that 3, 4 at the end, x in between, arrows to the left. However, look up. This one had a what? An equal sign. Yes. From 1 to 5, how comfortable are you with this so far? Yeah, we got this. Yes. Once again, these are and inequalities. All right. So check this out. Copy this one. Example 5. Example 5 reads 8 plus t greater than or equal to 7, or 8 plus t less than 2. You're like, that's weird, Mr. Q, I know. But it's done very similar. So let's start first on the left side of the or. I'm going to use red to start. Line down the inequality symbol. What do I do to solve for t, everyone? Minus 8. We're left with t greater than or equal to negative 1. Bring down the word or. I'm going to go to the right side. Line down the inequality symbol. I'm using blue. To solve for t, what do? Subtract 8. Subtract 8. We're left with t less than negative 6. Let's graph that. I'm going to start with this one. What is my dividing point for this one? Negative 1. Is it a solid point? Yes, solid point. I need to test which way to shade, so I'm going to test with 0. So instead of t, I'm going to put 0. Is 0 greater than or equal to 1? Yes, so I'm going to shade towards the 0. Next, the other dividing point is what? Negative 6. Open or close point? Open. I'm going to test the 0 as well to see if I shade towards 0. Is 0 less than negative 6? No, that's false. So I don't shade towards 0. I shade against the other side. What do you guys notice? Mr. Q, they don't intersect. Okay, so in between the gap, I want you to write the word or. So you remember that ors never intersect. Which are the only ones that intersect? The ands. The ands are the ones that intersect. From 1 to 5, how comfortable are you with this? 5, 4, 5, 4. Now check this out. For home plate, I mixed graphs and inequalities. But check this out. I want to get to these. Look at this one. If I was to ask you what kind of compound inequality is this, is it an and or an or? What would you say? And, because it's shaded in between. How about this one? And we'll stop right there, yeah? All right, once again, your home plate, literally copy the Nearpod code for tonight so you can get the home plate from there. 5FM4X, and your home plate should be coming up there. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye.